Welcome back to Best Academic TV. In this video, we're gonna focus on questions and answers on calculus. This is question 2. Now the question said, let y equal to 4 exponential tan s. Find dy dx. So we are asked to find dy dx here. So the options are given to us here. That is A, 4 sec square s, B, 4 exponential tan s, C, 4 exponential tan s cot s, D, 4 exponential tan s sec square s. So class, let's solve the solution first. Whenever you have any question on, please listen to me carefully. Whenever you have any question on differentiation, the first thing to do is to identify the function. Please take notes. Every function have their pattern of differentiation. Please take notes. So we have a question like this. Y is equal to 4 exponential tan s. So this question is basically on exponential. So how do we differentiate exponential, class? If you have something like this, a question like this, or an expression like this, y is equal to exponential u. This is an exponential question and function. To differentiate exponential function, that is the y over the u, that is dependent is y, independent is u. So our derivative will be expressed as dy over the u. So the format is this: differentiate what is at the top, take it down. So this will be u prime. You repeat the equation exponential u. So this is how we differentiate all exponential function. So if I have something like this, y is equal to class exponential 2s. It's very simple. So the y ds here, class, will be equal to differentiate what is at the top, that is differentiate 2s. I will have this to be 2. Now take it down, take the result down, repeat the equation will be exponential 2s. So this is how we differentiate exponential. So let's apply this format here in this question. So we are given this question: y is equal to exponential tan s. So what is that? Sorry, y equal to 4 exponential tan s. So we have to focus on the function part. So this is the function part here, okay? Now what is at the top of the function here is tan s. How do we differentiate tan? Remember, tan is trigonometry, okay? How do we differentiate any trig? If I have a function like this, class, please take note. This is a function, dy ds of it. If I have a function as sine, the dy ds of it will be cos s. If I have as cos s, dy ds of it will be minus sine s. If I have tan s, dy ds of it will be sec square s. If I have sec, dy ds of it will be sec s tan s. If I have cot s, it will be minus cosec square s. Okay. If I have cosec s, if I have cosec s, dy ds of it will be minus cosec s cot s. Please take notes. So what I have here is tan. So how do we differentiate? This is tan here. This is tan. So the derivative of tan is sec square s. So that means differentiate what is at the top here, which is sec square s. Take it down. So our dy ds dy over the s here will be equal to sec square s. Repeat the equation. When you repeat the equation, we have this to be dot. That is, dot means times exponential than s. And remember this, in mathematics, if I have this to be 3 times 4 is the same as 4 times 3. So if that is to be so, I can also rewrite or express this as 4 exponential tan s times sec square s, depending on the one that is the option. Okay, when you check the option, we have it as this, which is option D. Okay, so this is how we solve questions on exponential. So let's solve the next question here, class. Let's solve this question here. All right, let's solve this question here. This question 3 on questions and answers on calculus, and this question is on limit. They said limit of s minus 2 div over s squared minus s minus 2 as s tends to 2. Okay, now before we solve this question here, class, before we solve this question here, let's understand how to solve limit, the method of solving limit. Okay, solution first. Now, class, the first method of solving limits, any question on limit, the first method of solving limit is the direct substitution. Okay, now the next method here is factorization method. Or we can also use the Hopital's rule. The next method here is rationalization method. Okay. Now, do we use direct substitution method? Class, whenever you are given any question on limits, when the value of s tends to a particular value, a particular number, the first thing to do is to use direct substitution method. Please take note. But when you replace the value and the result occur to be 0, and the result of the denominator occur to be 0, that particular limit will be indeterminate limit. And that limit will be solved using factorization method or the Hopital's rule. Whenever you replace the value of s and the numerator give 0 at, whenever you replace the value of s and numerator is 0 and denominator is 0, that limit will be called indeterminate limit. And the method to solve every indeterminate limit is either factorization method or L'Hopital's rule. Please take note. But if you replace the value of s and the value gave 1 at numerator and 0 at denominator, the answer will be equal to infinity. Please take note. But if the value give us 0 over 1, the answer will be equal to 0. It's not going to be indeterminate. It's only indeterminate if you replace the value of s and the result is said to be 0 at numerator over 0 at denominator. And again, whenever you have any question on limits and that question occur to be a surd, or yes, a surd, it means that that particular limit question will be solved using rationalization method. Please take note. So this is the method we approach limits of a function when the value of s tends to a number, not when the value of s tends to infinity. So in our next video, we are going to understand, or we are going to, in our next video, we are going to understand how to solve limit at infinity. But whenever your value of s tends to a number, these are the methods we use to solve limits, either by direct substitution method or factorization method or rationalization method. Okay, now let's look into the question here. The first approach here to use is direct substitution method. Please take note. We have to replace the value of s. This s tends to 2 simply means s is equal to 2. So now let's replace the value of s as 2. When you do that, we'll have something like this, class. So this will give us this limit will give us limit of s minus 2 over s squared minus s minus 2 as s tends to 2. So our value here will be 2 minus 2 over 2 all squared minus 2 minus 2. So the result of the numerator gave us 0 over 2 all squared will give us 4 minus 2 minus will give us 4. So this will give us 0 at numerator over 0 at denominator. So it means that this limit is an indeterminate limit. Please take note. So all indeterminate limits can only be solved using factorization method or L'Hopital's rule. But this is what you have to understand here. If you are given this question in terms of essay, that is in terms of essay where there's no options like OBJ, okay, we use factorization method to solve that question. But if you are given this question in terms of OBJ where you are giving options, you use L'Hopital's rule, because L'Hopital's rule is shortcut method of factorization method, okay? L'Hopital's rule is the shortcut method, okay? Now let's use, since we are giving options here, let's use L'Hopital's rule. So before we use L'Hopital's rule, let's understand the L'Hopital's law. So if you are given f of s over g of s, it is an indeterminate limit. So to solve this indeterminate limit here, it means f prime of s, that differentiates this function here. That's what it means. Differentiate this function here, you have this part over differentiate this function here, you have this part g prime of s. Please take note. So let's apply this law here. So if I'm giving limit of s minus 2 over s square minus s minus 2 as s tends to 2. So let's differentiate. If we differentiate this, remember this is polynomial function. There's an invisible one here. Take 1 down to the base, subtract 1 from it to be 1 minus 0. Now this is a constant. Derivative of every constant is equal to 0. What is a constant? A constant is any digit that there's no attachment of letter to it. So I will have this to be over. Now class, differentiate this part here. This is going to be 2s minus 1 minus 0. Please take note. So I will have this to be 1 over 2s. I will have this to be 1 over 2s minus 1. Okay? But we are given the value of s. The value of s here, that is s tends to, remember s tends to 2 simply means that s is equal to 2. So replacing the value of 2, when you replace the value of s as 2, we have something like this class. Limit of s minus 2 over s square minus s minus 2 as s tends to 2 will be equal to class 1 over 2 into 2 minus 1. So this will be equal to 1 over 4 minus 1, which will give us 1 over 3. Please take note, okay? So the option there, okay, they gave us option. They said A, they gave us A, they said 0, B, they said 3, C, they gave us 1 over 2, D, they gave us 1 over 3. Of course, the answer is this, okay? So let's solve the next question, class. Okay, let's solve this question here, question 4, under questions and answer in calculus. Now we are given limit question here. That's limit of s squared minus 5 over 4s raised to 3 plus s plus 1 as s tends to infinity. So of course this one is very, very visible. As s tends to infinity simply means that this limit is limit at infinity. Whenever you are given any question on limit and the value of s tends to infinity, it means that that particular question is limit at infinity. Now, there's a simple way to solve every limit at infinity. Okay, please, this shortcut I'm going to give to us is only apply for limit at infinity. Now, To apply the shortcut here, you have to understand this class. You have to know the highest value at the numerator and the highest value at the denominator. If the highest value, that is the numerator, the power of the numerator is greater than the power of s at denominator, the answer will always take this part here, undefined u. The answer will always take this part here, u, and u is undefined. Undefined simply means infinity. Please take note. Now, the next one here is, if I have any question on infinity and the power of s at denominator is greater than the power of s at numerator, the answer is always this figure at the end. That is 0. Please take note. So the last condition here, if the power of the denominator is equal to the highest power of s at the numerator, we mute the rest and take the coefficient of the highest power at the numerator and highest power of the denominator. Okay, let's apply this here. From this question here, now the highest power of s at the numerator part is 3, and the highest power of s at denominator is 3, meaning that they are equal. So since they are equal, what you have to do is to take the coefficient of this is 1, is to mute the rest. Look, listen, please, listen. You close this, you take only the coefficient, you mute the rest. When you mute the rest, what will you see at that point? When you mute the rest, class, you mute the rest, that is, you mute the rest. You only take their coefficients. So I will do something like this. I will have something like this, class. I will mute this, the rest here. So our value will be equal to, class, 1/4. So this is our value here, okay? This is our value here, 1/4. So this is how we solve any limit at infinity. You don't need to solve anything. Whenever the highest power at numerator is greater than the highest power at denominator, the answer is always infinity. If the power of s at denominator is greater than the power of s at numerator, the answer is always 0. You don't need to solve anything at all, okay? Now, if the powers are equal, that is, the highest power of s at numerator is the same with the highest power of s at denominator, you mute the rest and take the coefficient of the highest power of s at numerator and the coefficient of the highest power of s at denominator. So this is how we solve every limit at infinity. This is a shortcut though, but all you have to do to get the method of solving this is to hit the subscriber button, okay?